And I'm going to turn my video off because I'm getting things cutting out a bit. Okay, so no prizes for guessing what today is about. We're talking about Anchor. Last week we went through what we call the bare metal approach to writing programs. Which is useful to go through. You need to understand at that level what we're doing when we're writing programs and how things fit together. But I'm sure you have found, you may have thought that it can be somewhat difficult, a bit awkward doing it that way, a bit unnecessary. It'd be nice if there was something to help us out, make our lives a little bit easier when we're developing. And that is what we get with Anchor. So what I'm going to cover today, let me zoom in a little bit. So we're going to go through a high-level description of what Anchor is, and then we're going to go down into lower level, and we're going to look at some of the types of tasks that we need to do when we're within our code, and look at them with or without Anchor, and sort of see what it is that Anchor gives us and how it simplifies the work for us. And we'll look at it in different areas. We'll look at where we're interacting with functions, accounts, and then things that we frequently doing, and particularly this what we call context, which you'll see is very useful concept and helps simplify our programs quite a lot. And then we'll just have a little quick look at testing and the kind of the general development loop that you go through when you're writing code. So we'll look at some specific aspects of that. Yeah, and then that'll be it. So I don't think this is going to take the whole lesson. I'll go fairly slowly because some of it is a little complex, but there should be time afterwards to carry on with the homeworks and the exercises. We don't have any exercises for today's lesson. We'll introduce some tomorrow. We'll continue going through Anchor tomorrow. We'll introduce some exercises then. Okay, and as always, please, if you have questions, pop them into Slido. That's the best place for us to answer them. Then everybody can see the question and can see the answer as well. That would be great. Okay, so Anchor. So this is a framework for making our lives easier when we're developing smart contracts and testing them and also interacting with them. And I'm not sure if there's an exact sort of equivalent in sort of the Ethereum world, but this it really does make things easier. And it's quite it has quite a wide scope because it deals with not only the programs themselves, but also helps us with the clients as well. And the way it makes our lives easier is that it abstracts away a lot of the sort of detail that we were looking at, we saw last week when we're interacting with our programs. A lot of the details, such as serialization of the of parameters and account details, it allows us to abstract away a lot of the details of the calls between the RPC calls, so the calls from the client to the program. And this is based upon an interface definition language. So this is something that is built that specifies how the program and the client are going to talk to each other. And it also allows us to do additional checks, so to set things up within context, as we shall see, that allow us to do checks about details of our accounts, for example, and we shall see an example of that later on. So the configuration, there's a configuration file, a TOML file. I think this is straightforward and to be expected. So in this, you can specify which network you're using, what programs that are being used within Anchor, and any customization if you have special scripts that you're using, or for deployment or testing or whatever, you can specify all of these in the configuration file. When you create a new Anchor project, this will get auto-generated, and then you can add to it. The components that Anchor gives us, and the way to really approach Anchor, are in these three sort of distinct components, which are functions, contexts, and accounts. And that, I mean, functions and accounts you're familiar with. Contexts, we shall sort of see how they fit in a second. But let's go through each of those now. So functions, yeah, the logic within our program, and mostly what we're doing when we're calling a function is we want to change some state, and so we'll need to do some deserialization and serialization of at least one account. Otherwise, our program's not going to really do anything. And so, Anchor helps us with this and helps us abstract away all of that, the details behind that, by using various macros. And then context. So this is these are lists of accounts that are going to go to a particular function and what we need to be done within that function. And it's similar to, you do get the idea of context in other languages as well, really the context in which a particular piece of code is running. So it's almost like the kind of the environment, what is available to you when you're running some code. I think it's sort of heading towards the kind of things like dependency injection, those types of ideas, if you've come across those in traditional programming, although I don't think it's quite there, but I think it's heading towards that. And then accounts, we've come across accounts before, obviously, and this is where we're going to be, where we have our state, or where things we're going to be using for example, access control checks. Okay. In terms of the origin of the name, there's this. I thought it's quite nice, because particularly the idea that there's this sort of drift in this ocean and this untrusted data that will cause you to drift in uncertain directions, but here comes your anchor and it's going to lock you down and sort of keep you steady within that. So quite a nice idea. In terms of what's the good and bad points from this, so this is quite subjective, but what we found good, it allows you to concentrate on developing business logic rather than having to spend all your time looking at the sort of the nitty-gritty of serialization. It provides you with some more flexibility around way accounts are used, and avoid some errors with that you may have come across. And I think, excuse me, in I think it was last lesson or the one before, there were some questions about this where you sort of came across this problem. It allows you to give the same type of functionality, but with much less boilerplate code. So your code's going to be cleaner, it's going to be easier to read and easier to understand, because you don't have to wade through all of that boilerplate code. And it handles a lot of the details around instructions, so you won't need a module specifically for that. It's not perfect though. and it is still being developed. Yeah, you should remember this is, I mean, Solana itself is relatively young as a system, and Anchor even more so. So there are still areas that are going to be difficult. If one of those is actually the first 2 points here, I guess, is that you can get errors that may be misleading or confusing. And often, if this is things where Anchor has done some boilerplate code for you and some error has occurred there, then when you see that error, it may not be super obvious as to what that is about, or to work out where the actual problem came from. I think this is true of all frameworks, and I'm sure this will improve with time with Anchor as it's developed further. You can get more granular control, but to do that, you have to expand the code. So you can run Anchor expand, and then that will sort of do the opposite approach. So it's, instead of abstracting it, then it will sort of push out all of the kind of the bare metal code if you need to do that. But that is a bit of a not exactly a last resort, but it's a bit of a drastic thing to have to do. It would be nice if there was perhaps a more flexible way of doing that, but we don't have that at the moment. There is, because we're dealing with different languages, and we have this interface definition language, we have different conventions regarding those. And so we'll have some conventions for Rust, such as snake case, but if we got TypeScript, then you're meant to be using camel case. So that can get a little bit confusing and can cause some errors as well. And I suppose it's not very intuitive either. It is quite specific the way that you have to work with it. It doesn't really sort of correspond to things that you've necessarily seen in other areas outside Solana, other than sort of doing the bare metal things. Okay, so that's a look at the high level, and then if we go into some more detail and look at what it can give us. So we'll start off by looking at the function calls, and without Anchor, if we're doing this in the bare metal code, if we're providing the boilerplate code ourselves, it can be you have to be very specific and very low level about this. There's an example that we went through that shows you this, but you have to, you're specifying what various bits are within a buffer. It's not super obvious what this means. You have to be careful to document this properly, and obviously it's easy to make a mistake about that. And you have to set this up so that then you get everything in the correct order, so that this can then be sent off to the RPC node. And then having done that, you need to then you also need to assemble instructions as well to send to the RPC node, and it's all rather complex and convoluted, but we need to do this so that the deserialization, when it happens, all comes out in the correct order, even though maybe that's not necessarily obvious to us why this order should be what it is. So that's, if you're not using Anchor, that's some of the problems you would face. But with Anchor, it's much easier. You can sort of do things more directly from the client, because we have this idea of the IDL, and we don't need to go through a specific instruction decryption module that we did when we were doing boilerplate, which was just concerned with the serialization of our instructions. It's all done for us with the macros that we specify in Anchor. And so rather than what we saw before, sorry for the typo here, we have an example. If we can in Anchor, in our program, we can specify something like this. So again, it looks it's the kind of thing you should recognize from what we were doing before, in the fact that we're passing things in to our function. In this case, we're passing in some type of context with some arguments, and then it's going to return us a result to say whether there was an error or not, or whether it's okay. And then from that, if we have that kind of set up within our program, then the client's code becomes much cleaner, much simpler, as you can see there. So you can just sort of chain together these different pieces and then do the RPC call there. So as you can see, much cleaner, simpler, more readable approach that you get with using Anchor, as opposed to having to do everything yourself and look after all the kind of the serialization there. So that's in terms of the functions. And then for accounts, obviously we have to pass those as well. So again, let's go back to if we didn't have Anchor, looking at the client side, we'd be using something like Bosch for serialization, and we'd have some TypeScript code that would look probably something like this, that we would have to get set up to set up our accounts and to get them serialized. And then you'd have to include those in your RPC call, obviously, with the along with the instruction data that we had, and then that's on the client side. On the program side, then you would need to unpack the accounts, and as I said, you have to be careful that the order in which you're doing these is being done correctly, and also you need the specifics of the serialization for that account. You need the structure of that account so that you can deserialize it and make some changes and then serialize it again. So there's a lot of things that you have to specify correctly and precisely. There are cases where you have to make sure that different areas of your code have to match exactly. So not your Rust code has to match up with your client side code very accurately. So very easy to make an error with that, and quite time consuming. And as your code becomes more useful, you add more complexity to it, more functionality to it, then the whole thing becomes more fragile, really. So there's more chance of you making an error. And you have to, I'm sure you'll recognize this sort of code that we saw last week when you're trying to deserialize something into a struct for an account. And then once you've done your code, whatever your code is, then you have to serialize it back and do something that looks like the second piece there. So quite convoluted, involved, not easy to read, not obvious perhaps what it is doing. So thankfully, Anchor helps us with this, and let's us sort of step back and forget a lot of the details about that with the serialization, because we have this. We can specify this macro for account, and then this will apply to the data structure that follows it. So we'll see tomorrow when we go through the example of a lottery. We'll see how all this works. But we've got here some details of the data, the state of our lottery, and then we're applying this macro to it, so that will then handle all of that low-level detail for us. And it's also Anchor will then provide us with the interface description language at compile time, which if you come from a Solidity background, that idea is similar to the ABI. So it's just kind of describing the layout of functions and data structures, etc. So once you have that, the client-side code is much cleaner. You need a little bit to set up, but then you can specify details. You can specify the fields from the account much more easily, and the whole thing becomes more readable and more obvious of what it is trying to do. So here we're getting our lottery account, which we specify the one we want by some public key, and then from that we can choose the I think which field was it? Was the winner index? Yeah. So we're choosing this field here, the winner index field. So it's an integer that we're pulling out from that. So as you can see, much cleaner code, much more obvious what it is trying to do, and you're much less likely to make a mistake. And a lot of this synchronization that you need between the program and the client is handled for you because we have the IDL. Now we'll go on to now to look at context, because this is quite a large part of what we need to do, and it helps us with common tasks really that we have when we're writing our programs. Excuse me. Because we interacting with the blockchain, we're often going to be doing similar things. We may be wanting to, for example, create new accounts, or to check some access control, or check some details about our account. And context is a nice way of encapsulating that, quite a neat way of doing that. Question, what do you mean by macros? Sure. So let me just go back to the example. So here you can see the hash and then account. This is a macro in Rust, which is there to do some, it sort of fills in some code for you. It will create something for you. In this case, it's creating some functionality around this data structure. If you look through, in Rust, you go back to some of the examples that we've had in Rust, you'll see we use macros in many places to do some tasks for us. So it's a way of saving some work for us. Yeah. Okay. So so the macros here can help us with some of the common things that we want to do, and we use context for these. And these we give a specific context for a particular function call. So a particular function is going to try to do something, and we'll set up a context for that particular piece of functionality. We can do when we set up the context, we can specify that certain accounts belong within that context, but that other accounts may not belong in that context. And so that's what this remaining accounts invocation here is doing. So just to mention that, so we're just sort of splitting up the accounts as to where we're applying a context and where we are not. So when we're doing this on the client side, it may be that not every account is applicable to a particular context. So we'll go through some examples here of some common functionality and how we've created some context to help us with that. So what we need to do within our function, within our program, we've got an example here. So this is some initialization within our program. We're initializing a lottery, and so it's not hard to believe that as part of that, we're going to want to create some items. And so we specify in the function signature that we're going to pass in a context. And this, we're using generics here to specify the kind of the type of the context here. So it's a context of type create. And we also pass in an integer for the price of a ticket. But then, so we need to create, we need to specify what this particular context is that we're going to use. So this create context. So we can specify it here within this. And so what this is doing is that we're using this when we're initializing our lottery. We want to create some details. So here we're saying we want to create an account, and we're telling it how much space that account is going to need, and we also say we're specifying who is paying for this, which is the account we called admin here, because when we're creating an account, obviously we have to pay for that, pay for the setup, the rent up front, and we're also passing in other details, and these are details that are unchecked. So we're passing in details of an oracle, and we're also passing in the system program as well, because that's going to be used when that's needed when we're doing things such as creating accounts. And yeah, so we're creating this account called lottery here. Yeah. So that's the example of some context that is set up that we use when we're doing the initialization of our program. So you can see that will be quite a common use case when we're starting a program. We'd want to initialize it and set up some basic details about it. So it would make sense to have the some context specific to that. And then the next kind of thing that we will be wanting to do with our lottery, we want to submit some details for playing in the lottery, so we can create a context for that. So once again, we've got a particular our submission function, and we're creating a specific context for that. And in this case, this context is all that we need to submit for this. And in this one, we've gone into a little bit more detail, so I'll try and talk you through that. So we want to create an account, and if you remember when we talked about PDAs and we talked about how these are created and the schemes we need to do this. We talked about the seeds and how we can set up schemas for those seeds so that they make sense and so that they can be, the accounts can be created in a structured way. And so that is what we're specifying here. We're specifying how the seeds that we want to use to in our creation of the account, how they are to be decided. And for this, we have a particular piece of state, which is a counter that we're going to use. And so that's the basis then for our seed derivation, which is then going to be used to derive the accounts. Again, we need details of who is going to pay for this and the amount of space that this account will need. And then again, we need to specify the system program because we're creating accounts, etc. We're passing in details of the player who's done this, and the lottery where we're storing we're storing our counter that we're going to be using to help with our seeds. So we're passing those details also. So you can see how nice it is that we can encapsulate all of these details all within one structure here, and then pass those in to our function. And then finally, we would have, our lottery would have a winner. We'd have some function to pick the winner. I think in this case, we're passing in some index here. You see a U32, which is our winner index. And so we create a context around the winner as well. I'm sorry, the formatting has gone a little astray here. Sorry about that, but it's okay. So you can see a similar thing to what we had before, but in this case, we have something extra in that we have a constraint here, and we're passing in for this. We're passing in two accounts. So we have the lottery account that we've used before, and then we also need an oracle, and which is going to be signing data as well to prove that it is valid. And we've put in a constraint here, which is a way that we have of tying these two accounts together and constraining details about those two accounts to make sure that we have the correct accounts when they are passed in. So when we do this, we're making sure that we have the correct oracle that we are expecting, and that constraint will enforce that and will throw an error if it's not true. Okay. So those are. So this is the account macro. There are many different ones. I have a screenshot of some of them here with details, but there are many. So there's a link there. Hopefully that's So you can see some of the options you get there for your account. Okay. All right, so that's details of the context we use. And I hope you'll see that this does simplify what we're passing and provides us with some quite nice, I guess, sort of compartmentalization of what we're doing in a way. It makes it much easier to kind of read and be specific about the functionality that we want at different points within our code. Okay, and then if we come to the actually using Anchor and how we test it, the loop we go through. This is similar to other kind of development environments, I suppose, and that's there's a kind of a build and a test that you can go through. So you can go through, you can do Anchor build to compile the code and produce the IDL and all of the boilerplate, etc. And use Anchor deploy to deploy your programs, and this will depend upon what you've specified in your configuration file, the network that you have specified there, and then you can run the tests. Now you do have some options about that. If you do, I think it's Anchor tests, that will run everything within your test folder, or you can specify a particular test with Anchor run tests. If you do if you do Anchor tests, sorry, not tests, you do Anchor test, that will go through the whole build and deployment process again. So it may be that you, rather than doing Anchor test, you would just want to do Anchor run test each time if you don't need to redeploy. Now, one drawback of Anchor, which I think is still the case, but is being addressed, I think, is around the program address. So this is still a little bit awkward, but I think it seems to be the kind of thing that would get fixed. So fingers crossed this will happen. But it means that you kind of have to repeat the process, really. So if you remember the way that we've done builds, and we get a binary, and then we get a key pair file as well. But what Anchor needs is it needs the address of this already. So it means that we have to do the process kind of twice, so that we can get the address and then we can put this into our configuration. So we do we get the program ID, as you can see here, and then you need to copy that into the configuration file, your Anchor TOML, as you can see there, and then also you need to have that within this declare ID macro as well. So you need to put it in a couple of places. So you need to put it in the code, and you need to put it into the into the configuration. But once you've done that, you can run the deployment. You can recompile and redeploy, and because you have this JSON file already that you've created the key pair, then and you specified these things, then Anchor will have all the pieces it needs, and it can carry on with the process. Okay. Yeah. And then testing, you can create specific scripts to do your testing in specific ways, as given by this screenshot, and you can choose to run particular ones of those by doing Anchor run, and then, oops, sorry for the typo, some sort of script name there, if you have different configurations that you need for your your testing. You have the advantages that you can still log things with the MSG macro, and then pick that up running Solana logs. And you can do some checking as well with of the state, so you can check that the state transition is what you expect it to be. So it works nicely. I think this is Chai, isn't it? So you can do this kind of statement here where you can expect the winner dot two dot not dot two equal loser to check the state afterwards. So yeah, that's quite useful. And then it also, because it's using Web3 library, then it can also give you some of those standard functions as well, more sort of the, I guess, the blockchain functions that you might use. And the imports of this is, I guess, a little bit neater if you look at that. So if you're not doing it in an anchor test, you would probably use something like that. This is the kind of thing, the bottom thing there, if you do it within an anchor test. So yeah. Okay, that's everything. That's the first part. We'll talk about anchor. We'll continue. We've got a couple more lessons about it. We'll go into it in a bit more detail over the next couple of lessons, and we'll have some examples as well to go through with you to give you a good idea. But I think it's probably useful. There's quite a lot of information in this, so it's probably useful if you want to spend a little bit of time looking through this and making sure that this all makes sense to you, and you understand what it is trying to do, and how it fits in to the what we're trying to do in development generally, and also what it has done and how it fits in with what we did last week when we were looking at the bare metal examples, and how we've sort of simplified that. So yeah, I'm exactly on half time there. So I'll finish there. As always, please put questions into Slido. We'll be happy to answer them. And for the rest of the lesson, if you want to carry on with the homeworks and the exercises we've already given you. Also going forward, it's probably useful for you for your team project if you want to use Anchor rather than using the sort of bare metal approach. Yeah, I would recommend that. It will make your development lives a little bit easier, which is always good. All right, so that's everything from me. I'll finish there, and yeah, please do ask us some questions. Thank you. Okay, I think we're almost up for time now. Tomorrow we will be carrying on with Anchor and going through some more examples, and then the day after this, it's a team project day, isn't it? So yeah, that's what we've got for the rest of the week. So thanks everyone for joining, and I will see you tomorrow. Thank you.